Okay, now we're going to look at mixtures. A mixture is a combination of two or more elements. Okay, and it's important, I want you to underline two or more elements and or compounds that are not, okay, all caps that for me, not chemically bonded. Okay, therefore each substance keeps its original properties or its identity. Okay, so a mixture is much different than a compound, which we just previously learned about. Okay, so we're going to go a little further in depth about mixtures. Okay, so there's write this, they're not chemically bonded. Okay, now this is the huge difference between a compound versus a mixture. Okay, is that mixtures are not chemically bonded. So let's look at some mixtures. There are actually three types of mixtures. On the left side of your fund, the first one that I'm pointing to, I want you to write, is a solution. Okay, so the first type of mixture we're going to talk about is the solution. Okay, in a solution, one substance is dissolved in another. Okay, and what that does is that gives you an appearance that you just have a single substance, but in reality you do not. Okay, so the solvent, okay, in this example of the picture that you see, the solvent here is what does the dissolving. So in this example, that would be your water. Okay, and then we have the solute. Oh, let me draw my arrow to the water. Okay, and then we have the solute, which is what is actually being dissolved, or what is dissolved. And in this scenario, it would be your sugar. Okay, so when you get finished, you have a sugar solution. Okay, but it only appears to be a single substance. Okay, so this is an example of a solution. Okay. All right, so here's some more examples of solutions. You have soft drinks. And the reason why a soft drink is a solution is because you actually have carbonated gas that is dissolved inside the water. That's what happens when you shake up your soft drink and you pop the lid. That's what gives it the big fizz or the fizzle. Okay, and gives all its gas being given off because it had been dissolved inside of the water. Okay, tap water, believe it or not, actually has minerals that are dissolved in water. Okay, not distilled water, which we'll talk about in just a minute, but tap water is actually the solutes that are dissolved inside of tap water. Okay, let me go back. Sorry. Tea, gasoline, believe it or not, steel, which is carbon and other elements that are dissolved in iron, and brass, believe it or not, is just a combination of zinc dissolved in copper. Okay, but they're not being chemically bonded. Okay, one is just dissolved inside the other. All right, now we're going to look at suspensions. Okay, a suspension contains particles of different sizes. Due to gravity, these particles will actually separate based upon density over time. So if you leave them sitting out long enough, they're going to separate. And in this example here, we have salad dressing, of course, and when I mean salad dressing, Italian dressing specifically, I should have put that. You're going to see that oil is going to rise to the top, and the more solid pieces are going to go to the bottom, and that's due to the different densities. Okay, also a snow globe kind of gives you an illustration of what a suspension is. Okay, let's look at the third type, and this is called a colloidal. All right, and this falls somewhere between a solution and a suspension, okay? And what it is, and I want you to underline between, but different particles are mixed throughout. However, the particles are not, underline not, large enough to settle out, okay? So it's somewhere different from a solution and different from a suspension in different aspects, okay? But it's somewhere in between. Now, examples here would be milk. Milk make up blood normally. Under normal situations, we would consider a colloidal. Detergents, mayonnaise, Jell-O, whipped cream. Okay, so these are things that have been heavily, you would think, are one thing, but they're not. Okay, they're not a solution in that they're not dissolved in each other. It's just that they're so well mixed up that they're a little more difficult to separate out. Okay, so these are the three types of mixtures. Now we're going to look at some methods to actually separate mixtures. Okay, the first one here is distillation, and that means to distill something out. And I'm going to walk you through the process. So here we have salt water set up at this apparatus, and we're going to apply this heat to it. After that, you're going to see the thermometer rise. This water is going to start to boil. Okay, as it boils, all right, in this tube, the condensation is going to go there. Okay, condenses, and when you do that, then you get pure water. Now, we have just separated the salt from the water. Okay, so what will be left over here and where we started if this process went all the way through? We'd have salt in one container, and we would have pure water in the other. Okay, so to distill something is an example of how you can separate mixtures. Also, they do this to make your liquors. Okay. All right. The next is, this is called centrifuge. Okay, and centrifuge is you take, if you give blood, or if they're wanting to do some kind of blood test, they can actually centrifuge your blood, and they'll take your blood, they put it into a centrifuge machine. It will go round and round and spin and spin and spin, and what you will find out when you get finished is that your blood is made of different components, the top part being plasma here, and the bottom being red blood cells. Okay, so centrifuge is one way to separate mixtures. All right, the next one is filter. Okay, and here in this picture, we just took some filter paper, we took some dirty water, and if I pour that dirty water into that filter, you're going to see at the bottom, you're going to come up with clean water, and your filter will catch the dirt. Okay, so filtering is a way. The next one, this is called chromatography. It's a fun one. Okay, you can do it with different pigments. Here, what they've actually done is taken, let's say, a black magic marker, and they've marked on a piece of filter paper. They've put it in either probably water or rubbing alcohol, and then that's where they're putting it down in there. And then what you're going to see is these different colors start running up the paper. So what you see from chromatography here is that you're actually able to separate the different color pigments when all you originally seen was the black color. Okay. All right, now this is using a magnet. All right, some elements have characteristics that make them magnetic. So if you use a magnet, in this example here, it would pull away the iron. Okay, in the bottom right hand corner, I want you to write your name where that big empty space is, and this is the end of this fun sheet.